Good afternoon, everyone. At least it's afternoon where I am on the lands of the Boonwurrung, just to the southeast of Melbourne. My name's Mark Hatwell. I'm from Monash. I'm also on the ATEM board and also on the steering committee of this conference. So we're looking forward to a good session today to start to lead us in towards the end of the conference. I'm delighted to session. It's a short story of interns, reality capture and space management at Swinburne. And the presenters from Swinburne are Amir Anusharavani, who's a senior space planning analyst, and also Will Joski, who's the principal advisor of building information modelling at Swinburne. Just some reminders before we start. You've probably heard of this a few times now if you've been in a few sessions. If you're posting anything about the session on social media, remember the hashtag #TEMconference. If you're having any trouble with video or audio, then look for the red headset in the lobby section to contact the support team. Just remember, if you're submitting questions for the presenters, please use the live Q&A. You're welcome to use the discussion forum for observations or chat with your fellow delegates, but live Q&A is where we'll be looking for questions for the last few minutes of the presentation to put to the presenters. And any questions we don't get to, the presenters can follow up with you afterwards via the Q&A tab within the conference portal as well. So with that, I will pass over to Amir and Will to take us through the presentation. Thanks.
Everyone, I'm Amir Anusharavani. It's great to be here today with you all. My role is Senior Space Planning Analyst at Swinburne University. There are two other speakers to introduce shortly, but first, the project we are presenting today. How reality capture was used to enhance Swinburne's space management platform with the help of work-integrated learning students. The project is to implement new technology as part of Digital Future at Swinburne in line with our strategy. The key part of our project is about working with the resources and intelligence that already exist within university. So hence, we will talk about Swinburne's work-integrated learning program. And we hear from my colleague who's developing training and education at Swinburne's Advanced Construction Technology Department. Another important thing before we start is that I would like to emphasize we are not seeking to give a definite answer or a final product. Our goal has been to demonstrate a proof of concept. As a proof of concept, we like to identify the strengths and flaws. In this way, success is not dependent on being 100% right, but rather being curious, considered, and open to what we discover. That way, we can engage with the stakeholders in facility services group and generate conversation and identify the next step folding back in the lesson learned. So in this session, we have divided the topic into three parts. In first part, I will take you through the project as an introduction. In part two, we discuss our WIL work integrated learning program and our amazing interns, Horace Lai and Sonal Shalia from Swinburne's work integrated learning program. We will hear directly from Sonal on her experience on this project. And part three contains the technical aspects of the delivery, where we will hear from Will Joski. Will is the subject matter expert on building information modeling, and he will relate the broader aspect of digital engineering technology and BEAM to our space management services. Now let's review space management system and how we saw BEAM as an important process to implement. For space management system at Swinburne, we use a combination of Archibus and SysFM. This is in consultation with our vendor IFM Integrated Facility Management, who also provide the ongoing support for our system. This is a combination of tools that I believe is similar to many universities, and I'm sure there will be quite familiar. Many of you would be quite familiar with this system. We've got currently all our AutoCAD two-dimensional plans captured and maintained in the system. We have different level of spatial data attributed to each space to assist us with the space planning and management exercise. This is a typical floor plan that you see on the slide. That's out of our space management system. In addition to this, we've developed an integration with our people and culture system, Workdays. This is to assist us with allocating staff in a space and desks, efficient people management, reporting, and also move management. We also have a great ambition to steadily move towards the use of building information modeling principles. This is to assist in integrated facility management approach throughout the whole life cycle. It is from tendering major projects all the way to the day-to-day maintenance activities. The goal for Swinburne is to improve project delivery by enhanced 3D visualization, tracking abilities, reporting, planning, digital information handover at the end of projects, and so on. So while this project only occupies a small corner of what I've just described, this is also in line with our long-term BEAM ambitions. Early 2020, we had COVID-19 and enormous impact on us. Working from home became the new business as usual and not a special circumstances anymore. It's prompted the need for better visuals incorporated into our space management system. Greater than before even. The visuals that allows the staff and the students to inspect spaces without the need to be on campus. And the question was we asked ourselves was, can we make this more useful? Can we give more than a static photo? Can we provide more information visually to enhance our user experience? Being short on staff and also financial resources during difficult time, we needed to be creative and seek resources already available to us. We came together as a team and determined how best to proceed. We needed to ensure we remained focused on solving a problem within the strategic context. So in another word, we were not going to throw resources and technology at project just because it looks cool or impressive. We will have more on technical solution and the broader context in a third part of presentation, but the solution we arrived involved a scanning technique called photogrammetry that quickly converts photography into virtual 3D models. So what are the advantages of this? The virtual 3D model that are created allow users to look up and down and measure heights and width. Also see spaces, how it connects and relate to each other, to understand the relationship between the space. The model also have the potential to give access to other information, for instance, the ability of this space to be an interface to a web page, to videos, database, health and safety material, and so on. The tool used to capture the spaces is a proprietary system called Matterport. You may have seen the similar solution used in online real estate virtual tours. We will review more on Matterport later on in our slide. This now brings us to our next part of our presentation, where we approached two of our most precious assets, WIL program students and subject matter experts in BEAM, to whom we were grateful to have as part of Swinburne, within Swinburne community. One of the most important parts was working with our work integrated learning students, Horace and Sonal. Not only they were both fantastic at learning and helping to deliver what we needed to deliver, also the WIL program offers benefit and opportunities for our students to exercise their learning in a real-world environment. To help resource the project, we took advantage of our comprehensive WIL program that offers a range of opportunities to both the students and industry to mutually benefit from each other. Some of these programs are professional degrees, partnership, internship, industry-linked project, accreditation placement, overseas study tour. We picked the internship program as we thought it suits best relative to our time frame and requirement for delivery and also financial resources. Through consultation with Will Josky, we laid out the project objectives and developed our project plan. We welcomed our WIL students to the project. We provide them with support and training materials, and that's how we started. Now I would like to invite you all to hear directly from one of our fantastic interns, Sonal Shalia, on her experience through the project in the following short video. Then you will hear from Wiljaski to take you through the aspect of digital engineering technology and BIM and how that could shape our current project moving forward. Thank you.
Hi everyone, I'm Sonal Shalia and I recently finished my Master's of Business Information System with a specialization in business analysis and started my new role as a digital finance technology consultant at Deloitte, Melbourne. So when I was first encountered with my mentors and came to know about the project, I was excited, but at the same time, the technology and the tool that we had to use were new to me. So it was a challenging situation at the start. The support that I got from the space management team throughout the internship was phenomenal. Also, access to the recorded sessions on BIM created by Will helped me in developing the in-depth technical knowledge required for this project. Yes, there were a few challenges that I faced at the start of my internship or during my internship, such as unavailability of the scanning spaces or doing or solving the problems on our own. So yes, there were a lot of challenges, but with the constant communication with my space management team and working collaboratively with the team helped me to overcome these challenges at the earlier stage. So talking about my responsibilities, at the start of my internship, I spent most of my time in learning how to use the Matterport scanner to collect the scans efficiently. Once I was comfortable with the Matterport scanner, my responsibilities were to collect the scans, get them reviewed from the supervisors, work on the given feedback. Also, at the latest stage, I was involved in developing a handbook for other interns to learn from what we did during our time. So talking about my work integrated learning experience, it was a memorable experience for me as I got an opportunity to work on a real world project. And also it helps me in developing the interpersonal skills such as communication skills, collaboration, leadership, and which according to me are the entry points to the professional world. And also at the same time, it gives me an opportunity to take a move from a university experience to a professional experience. Yes, I would definitely recommend this work integrated learning to students as it gives you an opportunity to apply your learnings to the real world project and grow professionally. Also, it helped me to prepare well for the next stage of my career. And also it helps you to grow your network professionally, such as the Swinburne team post a very good post for me on their LinkedIn. So yes, it definitely helped me a lot.
From industry in 2019 to develop training and education around building information modelling. My part of the presentation is to give an overview of why BIM is part of the strategic roadmap for Swinburne and how our proof of concept fits into that. BIM plays a renewing improvement of facilities and asset management. It does this by providing better information and data to those who manage assets, doing so in a digital format so that it can be used directly by those who rely on that information. As we go through our slides, you'll see us moving from big picture to little picture. We are reviewing some big picture elements around BIM to better understand how our proof of concept fits into those longer term strategies. So let's start with a little what is BIM about. It's digital, it's 3D, it's transforming the construction industry. And I'm saying present tense transforming, not past. It's still being understood and implemented by a very wide range of stakeholders. Anyone who has a role to play or an investment in the built environment is affected by BIM in one way or another. But don't fear, I've distilled BIM down to 5 ingredients for your benefit today. The first 2 are the nuts and bolts. They are the virtual 3D models created instead of drafting plans, and the information about what those models represent. They are connected together and can serve many purposes, one of which is providing a range of information on what has been built, an asset register. To keep that process of creating and managing the models and information, the third concept of BIM is defining project objectives and working to them. These objectives, or BIM use cases, are the building blocks of what the needs and limits are and what needs to be done. BIM is a collaborative process that encourages the various teams that use to work separately to work together. Hence the ability to exchange and combine the models and information to formalise and centralise the approach is the fourth concept. Lastly, as we'll talk about in the next slide, all this needs to be wrapped up in a framework that is predictable and common to all the project stakeholders. And in relation to that last concept, this is something BIM nerds like me have been very pleased about since 2018, which was the ISO standards on information management and BIM. These standards originated from the standards developed in the UK to enable their government mandate governments, and we'll talk more about that in a minute. So, standards, good thing, let's tick that off. The next thing in understanding the big picture, where is the best place to control the process and derive benefit from BIM? You might be familiar with some of the great things BIM can do for designers, engineers, and building contractors. It has a huge impact on all of the construction industry for vertical buildings and horizontal infrastructure, with positive impacts on process delivery, efficiency, stakeholder communication, de-risking, and waste reduction. Well, what I think is super important to know is that whilst BIM provides these benefits for the supply chain, one of its greatest impacts is its potential in supporting asset and facilities management. And this is the ultimate position for control and benefit. If we can imagine that those in asset and facilities management dip down into project delivery to update or establish new information, we can also imagine that they are at the base of the greater things that are possible. Information management is all part of the foundation of digital twins and our future cities. The new purple elements on the slide that you can see represent the concepts of digital twins for which there is an enormous amount of writing and effort being invested at the moment. The Gemini principles issued by the Centre for Digital Built Britain, I think, is still regarded as one of the best publications on digital twins if you want to research that further. But the main thing to take from all of this is that we, as an industry, now have a very clear path to walk when formulating strategies for the university campuses of the future. BIM and how it enables smart facilities management are an essential part of that strategy. I promise we're getting there, but this is also worth mentioning. Because on top of all of this, for us in Victoria, we have the Victorian Digital Asset Strategy, VDAS, that is now supported by the very recently released Digital Asset Policy. And thirdly, there is currently work being undertaken on reforming building legislation. Within the scope of this work is how digital as-built records that demonstrate compliance and building safety can be mandated. I believe this will be a game changer in how asset owners and the supply chain are held accountable. This is Victoria's example, but similar strategies and pathways are in the process of being delivered or are being delivered in other states and territories in Australia as well. So let's get a little bit closer to our project. And back with those 5 main ingredients in the BIM soup that I mentioned earlier, models and data, the first 2. At the core of project delivery is the information and the models that work with the information. These are built up in project delivery and handed over in operations. The virtual models created by designers, engineers, and builders are developed through stages. There's virtual design, virtual construction, virtual as built, virtual as maintained. And with a few more herbs and spices, we have the digital twins and future cities that are the aims of governments, universities, and many others. And when it comes to these virtual models, the question of existing facilities comes up. How will I create my virtual version of the physical that already exists? There are two main routes that can be taken. On the left, we have reality capture, such as laser scanning, which is fast, can be very accurate, but scanning doesn't create smart geometry, smart models, which may or may not be an issue depending on what you need. On the right-hand side, we have 3D modeling authoring, which is smart geometry, but setting out to create virtual models of existing buildings is far more labor intensive, time-consuming, and expensive to produce. So hopefully you can see now we're just getting a little bit closer to our proof of concept. And this is for our proof of concept, we went the scanning route. Now, a little bit more information on scanning. The investment in scanning can be significant, into the many tens of thousands of dollars. On the right-hand side, what you can see is an entry-level laser scanner that looks like a bullet. These are lovely little devices that sit somewhere over about $30,000. And next to that is a scanning device that uses photography instead of lasers and is roughly about 1/10 the price. The process it uses is called photogrammetry, and this equipment is what we use to capture space for Swinburne Space Central. And what you see now is the work produced by our work integrated learning students. Scanning equipment is placed at numerous points along corridors and in rooms where multiple photographs are compiled. This is then repeated and each scan point joined to the others as the building is surveyed. The entire scan is then uploaded to the cloud-hosted platform provided by the manufacturer. At this point, software identifies the common features in the photos and builds a 3D model which can be viewed as we can see here. To improve the visual experience, the walkthrough visuals use panoramic photos at each point a scan was made, as the model can look not very tidy and a little bit incomplete if we're looking at the model only. This 3-level building took 2 days to complete once our work integrated learning students were familiar with the equipment and processes. Matterport allows you to see the building as a model or as a walkthrough or in plan, level by level. Some things that Matterport allows us to do out of the box. One is to create tags like you can see here, placed at any location. Text, links, videos can be incorporated and viewed in full screen when clicked upon. Because there is a reasonably accurate 3D model created, Matterport also allows measurements of spaces so that users can check clearances. Say, for example, if you're moving heavy equipment, you can check those before you actually get on site. Our implementation of Matterport was to link individual room records in Space Central to the corresponding scanned rooms using what are called deep links. Deep links can be collected for each individual room within a building, and then each added to a new field or button or icon in SysFM. These links could also be sent to others independently of Space Central. For example, for a maintenance contractor, it could be provided in an email with other work order information. For students who are to be inducted into a learning space that has certain risks and protocols, it could be shared during an online lesson. The teacher can then guide and the students can explore not just one space, but all the adjoining spaces as well. The use of a virtual model to provide the experience of a space, as well as can also act as an interface to other information, and that's a key use case in facilities and asset management. By linking different sources of information, such as asset registers, work orders, condition assessments, OHS and hazardous materials warnings, there are many possibilities to be explored. And I think this will be one of the ways in which our proof of concept will be measured for success. Does it create conversation and engagement from which the next innovations and solutions are defined. And this is my bonus slide. Now, Matterport allows the models created from the scans to be downloaded. And from there, they can be used for any purpose you want. And in this case, we looked at how they could be used to create a virtual classroom. On the left is an example of a Matterport scan of a disused and hazardous industrial building. On the right is Mozilla Hubs, which is an online collaboration platform. Students enter a virtual space, they can walk around, talk to each other, be guided by a teacher, and so on. The industrial building, with some secret source model conversion, has been imported into Mozilla Hubs and could be used as a place where students are taught in a place where otherwise they would not be allowed access to. And I think that was pretty cool. So, what are some of the limitations? What have we learned? Accuracy. This is not so much a problem for us, as our main criteria is to see and experience the spaces. If accuracy of the models created from scanning was a priority, we would choose laser scanning over photogrammetry. Earlier, I showed how tags with more information can be made. A future possibility is also creating tags or hotspots that could link to other information. With photogrammetry and Matterport, this is all manual effort. There is no intelligence that would allow us to see specific equipment or know a certain space, know what it is, and automatically directly link information about it. Security is a large concern also, and how to control who has access to right. Updating scans over time may also be an issue. At this time, if there was a desire to rescan part of a building, for example, a new art installation in a foyer of a building, then there is a risk that the entire building would need to be rescanned. This might also put at risk any tags that have been placed manually into that model. These challenges can be overcome with different approaches and strategies. The key thing is balance. The value in having the virtual spaces available is it worth the resources to create and manage them, including some of the limitations that currently exist? And that's what we're working on. And that is the end of the presentation. And if there are some questions, we look forward to answering them. Thank you.
Thanks very much, Will and Amir. We've got one question that's come through. We've only got a couple of minutes left, so let's start with that one. Steve Haywood, thanks, Steve. The question is, what method do you use to transfer the asset data from the BIM system to your asset management system for future maintenance?
We don't have that built into this proof of concept at the moment. We're only looking at using a scanning methodology to create an user experience connected to the space management system. So whether or not using Matterport is a sensible approach to linking asset information to the FM database is yet to be seen. It may not be the correct route to go, and that's part of the exploration that we're conducting.
Great, thank you. Everyone else is just saying thanks, fantastic presentation, etc. There was one question that occurred to me, I suppose, from the context I've been dealing with is how much of the project was accelerated or advanced or maybe even blocked by having to work from home and the pandemic restrictions generally, especially for students?
I think that's a great question, Mark. It's the pandemic, fortunately, did not it did accelerate. Definitely, the whole idea was because of working from home pandemic, because the space management exercises didn't stop. We still had to vacate buildings. We had to find savings. There were a lot of relocations, restructures throughout the pandemic. So it definitely was a big motivation to start the whole project. But also, fortunately, our WIL students' work by not being on campus was not impacted. And the reason was because the timing wasn't the harshest lockdown that they were doing the work, still they could go on site within regulation, but also they preferred to be on site when less people around to be able to perform their scan. So in a ways, we had to give them a lot of autonomy for their work, and we were fortunate. I think that's another positive with WIL students, especially we selected the masters, both Horace and Sonal, they were master students, so they were working with a great deal of autonomy. They didn't need constant supervision, so we had weekly meeting with them and going through challenges they had. But yeah, so that's...
Thank you. There is one more question we might really quickly try and address from Daniel. Do you see technologies further improving in laser scanning or photogrammetry that will continue to change the game in this area?
Yes, I think when it comes to photogrammetry, in particular the Matterport product, I think we've got a couple of hurdles that as part of the software development that will really help a lot. So, for example, when we talked about the issue with security, IFM offered fantastic support to us when we were developing this, and one of the things that occurred was to see how we could improve the security. When someone was to click on a button in SysFM, would they be able to create a secure link to one of the rooms that they're looking at in that virtual model? And at the time, there wasn't that capability to do a one-time handshake in order to provide a secure access to an area that we don't want everyone to be looking at. I think that as Matterport finds more commercial sort of use cases, rather than, it's probably, I don't know if it's fair to say, but I'd say it's probably true that most of its work is in real estate type of applications, that it will start to sort of have a look at how it can extend its features to help solve some of these problems. I think long answer short, I think that, laser scanning will improve in terms of its technical ability. Photogrammetry will too, no doubt, in the way that algorithms.
Hello there. I hope that you enjoyed our last sessions. We are about to present.
I think that sort of the main part about this presentation was as a very accessible product, how useful can it be in this type of application in terms of
please join in and make welcome these wonderful presenters. Diane Van Eck, Director of Higher Education from DVE Solutions, Heinrich Wolf and Sarah Fayad from ACOM, and Dr. Samantha Hall, Principal Director of Campus Intuition. Please dive into these sessions and choose which one appeals to you and participate fully to make our speakers welcome. I'll be back after these presentations with the final sessions of the conference and to say farewell. Until then, enjoy the